这一场会用英文讲。I will speak in English for this talk. Okay. Hello everyone. Welcome to this session, Debug usage and debug introduction. And I'm Pan Jianhong, and my ID is Star Knight. Comes from Endless OS Foundation. And I will put this slide to the slideshare too later. Here's the agenda. Okay. When we're talking about the inter-process communication, IPC, it's a process communicates with another process for exchanging information. But how to implement it? The textbook taught us we can use the shared memory between the process, or the process can write and read the same file. This can combine as kind of pipeline. However, for the memory protection issues, programmers separate the process memory space totally. How about use the socket communication between the process? And why not? But there's the problem. You have to design the payload of the socket by yourself. Why not use debug library? Why debug? Because it is based on Unix domain socket, so socket. And the ecosystem uses, for example, systemd and the desktop environment, such as GNOME and KDE. If you use the Linux distribution, debug just like the air. Why air? Because you breathe it every moment, but you never notice it, which means you use debug almost everywhere in if you use the desktop environment. And it uses the server client architecture, and it already defines the data serialization format. And it provides methodical communications and broadcasting mechanism. Before we get into the debug deeper, this slide is more like a note extracted from debug specification and debug tutorial. And when we're talking about debug, it might be the debug specification or the message bus system. It includes a library libdebug and a message bus daemon. It is executable built on libdebug, and that multiple applications can connect to. The daemon can route messages from one application to 0 or more other applications. There are some wrapper libraries or bindings based on particular application framework. Some even re-implement by following debug specification, such as glib's built-in debug library gdebug. And there are also bindings to languages, such as Python, Go, and Rust, etc. And debug supplies two bus types. The first one is the system type. It is for system-related things. For example, network manager manages the network devices, and uPower is for the power devices on your system, and the udisk is for storage blocks. And another type, such as another bus type, is the per user organization type. It is for general IPC needs among user applications. For example, the GNOME files, and if you are non-Latin languages users, you need input methods engines such as ibus. And some applications use both. For example, systemd, GNOME Control Center, as well known as settings, and the GNOME shell, and more others. Now we understand that process try to communicate with another process. But how to address the resource on the debug server-side process? So debug defines three things: bus, object, and interface. Now we have the debug message bus in the center. And process A acts like a debug server-side process. It connects to the message bus with the connection. And the connection name is colon 34.907. It is assigned dynamically and hard to remember. So when process A connects to debug message bus, it also registers a well-known bus name, for example, com.example.food. And this bus name is maps to the connection name, colon 34.907. It's just like DNS maps to IP. And the process A has an object at path /com/example/food. And the object has an interface, which is com.example.food. And it has methods, properties, and signals. So other processes like process B acts like debug client-side process. It can address the resource of process A via the bus name, object path, and interface name, and also the members such as method. And you may notice the bus name and the interface name and the object path looks like a reverse DNS strings. Yes, they must be reverse DNS string. It is defined in the specification. I'm going to have an example here. For example, I try to get all of the power devices of this laptop. And we understand that uPower daemon manages the system's power devices. And it registers a bus name org.freedesktop.upower. So it is the destination bus. And it also has an object path /org/freedesktop/upower. And the object has an interface org.freedesktop.upower. And the interface has a method enumerate devices. And I'm going to use debug send command to send a method call message to the uPower. And because uPower connects to the bus with the system type, so it's --system here. And let's try it. This one. Okay, now I get all of the power devices of this laptop. It shows 3 objects here. The first one is the DC battery. Second one is the line AC power. And the third one is the USB Type-C. And if we want to know the DC battery's all properties, we can use another method called message. But this time we are going to, because we are trying to know the DC battery's properties, so the object path is the DC battery's object path here. And so it's a battery on the line BAT0. And going to use a standard interface org.freedesktop.debug.properties. It has a method which is getAll method in its parameter, which is the target's interface name. Because it's name, so it's a string types, which is org.freedesktop.upower.device. So let's try it. This one. Okay, now we get all of the DC batteries objects and the properties on the interface of org.freedesktop.upower.device here. And for example, I'd like to know how much power do we have right now. The percentage is 78%. And let's check the non-control center here. 78. Yeah. So this is an example. The GNOME shell or the control center access the uPower, try to understand how much power remains on this laptop. So use the same method code to get the property. Could be, but another thing. If we want to only know the percentage properties value, because we get all of the properties of the interface. But if we only want to get one property, we can use another method code, which is the get method. And this time we need 2 parameters, the interface and the properties name percentage. Okay, this one, 78%. Okay. Now let's talk about the message bus. The message bus accepts connections from one or more applications. Once connected, applications can exchange message with other applications that are also connected to the message bus. In order to route message among connections, the message bus keeps a mapping from names to connections. And the bus itself owns a special name org.freedesktop.dbus, and it has an object at path/org/freedesktop/dbus. And that object has an interface org.freedesktop.dbus. And the message bus daemon usually be dbus daemon. However, more and more Linux distribution moves to a dbus broker for better efficiency. For example, Fedora and Arch Linux. And let's talk about the standard interfaces. There are some standard interfaces across dbus applications. And the first one is the org.freedesktop.dbus.introspectable interface. It has a method introspect. It is a useful method. For example, if you don't understand the object's detailed information, you can use this introspect method to retrieve all the object's description in XML format. So you can understand and parse it. If you are interested in the XML format, and you can check the introspection data format document here. And here's an example. dSpy. dSpy is a dbus debug tool, and it shows all buses on this system, including the session type and the system type. And let's use the upower as the example again. Here it is. And it shows the connections here, which is the Unix domain sockets. And the bus name, org.freedesktop.upower. And here's the connection name and process ID. And when I click the objects here, dSpy will send the introspect method call message to upower. And it shows all of the objects description, including the interface. So it shows the interfaces here, and here's the org.freedesktop.upower interface, and it shows the properties, signals, and methods. And here's the enumerate devices method, and we can even click it and execute it directly, and it shows the power devices of the on this system. It's quite convenient. And another interface, org.freedesktop.dbus.properties. It has three methods: get, set, and get all methods. And get all we just used before. Set method means set the interface's properties with the value. And it has a signal which is the properties changed. When the properties value have been changed, then the properties change signal will be emitted and broadcasting on the message bus. So other process can catch the signal and handle it. And you may notice the methods has some parameters, and the signals has the data. They all have the data types here, and as well as the properties. So dbus defines some basic types, such as the bytes can be represented by the character Y, and boolean can be represented by the character B, and the string is the character S, and the container types such as the structure or the parentheses. And the array is a string started with the character A, and the dictionary is curly brackets. Now, here's a small recap. When the client side, dbus client side process try to address the resource on the dbus server side process, it needs the bus name, object path, and the interface name and the methods. And dbus communication is based on the Unix domain socket. So we can use the socket text command ss-a and grab with the keyword dbus. So it shows all of the dbus connections here. And dbus also defined the message types. The first one is the method call message. When dbus client send a method call message to the dbus server side, dbus server side catch it and handle it and return the method return message to the dbus client side. or an error message. And another one is the signal message. When something happens on the debug server side, it will emit a signal and broadcasting the signal among the message bus, so other process can catch the signal and handle it. Now we have a debug message bus in the center again, and the process A acts like a debug server side process. It connects to the message bus with the bus name, and process A has some objects, and each object has some interfaces, and the interface has some methods, signals, and properties. Other process connects to the message bus, and for example, process B send a method message to process A, and process A catch it and handle it, and it returns a method return message to the process B or an error message. Or something happens on the process A, it emits a signal and broadcasting the signal, so other process such as process B and C can catch the signal and handle it. Now, we understand that the debug message fly among the message bus. Can we debug it just like a sniffer on the network devices? Yes, we can use the debug monitor command or a GDBus tool or graphic UI tool buses. It can be installed via Flatpak. It is convenient. And another one is the debug spy, and this spy we just used before. I'm going to use the debug monitor, for example, here. And I'm going to plug this USB disk to this laptop. And we understand that all the storage blocks are managed by UDIX. And it has an object at path/org/free desktop/udisc2. And because it connects to the message bus with the system type, so it's -- system here. Let's try it. Okay, I'm going to plug this USB disk to the laptop. Okay, we got some signals here. Here's the signal, and here's the name, signal's name interface added. On the interface, org.freedesktop.debug.object manager of the object udisc2, and it is a USB device, and it's SanDisk 32 Gen 1 USB disks. And here's its serial number. And we can use LS USB -- verbs and grab the serial string here. Then it shows the serial. So it's a USB devices here. Okay, and system puts it at /dv/sdb, and it has an partition sdb1. And if you don't know the keywords, you can use the buzzers to catch all of the debug messages and click the checkbox on the left panel to filter out the information you are not interested in. And here's the filter result, and you can see the connections, which means the process. The connections belongs to the process, so you can see the process relationship here, and also the sequence. And for example, here's a signal, and it is interface added, and the signal's data. Now we understand how process communicate with each other via the debus. So how about the write applications using debus? I prepare a chat debus run as an example. It has a GDBus server, GDBus client, and a Python version, PyDebus client. I put the code on GitHub, and so you can clone them directly. And the clients have the text view, so they can show the chat information on it. And here's a scenario. A debug client use the send a message method. So debug server catch the method call, and it handle it and emit a signal, which is the message notification signal. and then client broadcast, because the signal will be broadcasted. So clients can catch a signal and handle it. For example, put the message on the text view. I'm going to use the GDBus API on both server side and client side. And let's go to the code here. This is the GDBus server. And here's the bus name is io.starnight.debug_test.test server. And the object path, interface name, and I also prepare the object's description in XML format string here. The object has an interface. The interface has a login method, send message method, and signal message notification, and the property, which is the title. And let's go to the main function. The first step is load the XML format description into memory, and by GDBus node info new for XML function, and save it as an introspection data. And then the GDBus server connects to the message bus, and so we use the GBus own name, and the type is the session type, and here's the bus name. And when the bus is acquired, on bus acquired, callback function will be invoked. So let's go to the bus acquired. Okay, bus is acquired. So we can register the object to the connection. Here's the object and here's the connection. With the GDBus connection register object function. And here's the introspection data related to the object and the interface vector table. It holds the handlers for method call, get, and set properties. And let's go to handle method call function. Here is it. Okay, if the method name is send a message from the debug client side, then go to the handle send message function. Okay. The first one is parse the data from the send message call method, which has a parameter, and here's how to deserialize the data payload as the message. And the debug server side emit a signal, which is the message notification. And here's the connection and the object path and the interface name. And the GDBus connection emit signal is the GDBus function for emit signal. And it brings two parameters. And here's how to serialize the data. The first parameter is sender, second one is the message. And let's go to the client side. Okay, here's the bus name, object path, interface name, and another one is the standard interface org.free desktop.debug.properties. And when the GDBus client is launched, it connects to the message bus too. So use the GDBus processing new for bus sync function and save the connection as the proxy. And the bus type is the session type again because GDBus server connects with the session type here. And here's the target bus name, object path, and the target interface name. And the client side use the send message method call to send a message. Okay. How to send a method call message? We can use the GDBus proxy call sync function to do that. And here's the connection, which is the proxy, and send a message calls method names, and here's the data going to be sent, and which is the message, and here's how to serialize it. And when another thing is when GDBus server emits the signal, which is the message notification. So GDBus client want to catch it, so we have to combine the signal to a callback function. We can use the G signal connect. Here is it. Here's the proxy, which is the connection. And when the proxy gets a signal, go to the callback function, debug signals handler. And if the signal name is message notification, then go to the message notify handler. And here it is. So GDBus client get the signal, catch the signal, and the first thing is deserialize the data. Here's the deserialized format, and we can get the sender and the message here. And combine the sender and message as the text and update the text to the text view to show up the chat information. Now let's execute the program here. Because I already built the code, so I can execute them directly GDBus server. And how about monitor the communication between the server and client sides and run the clients here. Here's the GDBus client and the Python version PyDBus client. Okay, now we have the client and server here, and here is debug monitor. Now let's send a message. For example, hello cost cap. Okay, so GDBus server catch the send message method call message and shows the message here hello cost cap. And from the debug monitor, we can see here's the method call, send a message, and brings the message content hello cost cap and emit the signal, which is the message notification. And the signal has two parameters: the sender and the message content hello cost cap. So all the clients catch the signal and shows the sender and message content here. So, yep. Now I put a reference here. If you want more information, you can check it in. And one more thing I haven't mentioned, because which is the GDBus codegen. You may notice I write the handlers of the GDBus server for the interface vector tables, including the method call handler and the set and get properties. But in the real world, most people don't do that. People use the GDBus codegen to generate virtual functions, or I don't know how to explain it. It's like a skeleton, so you can add more codes there, which means it generates interfaces for you automatically. And if you want to have an example, uPower is a good example. And another thing is if the message bus can start the systemd services like activation, which means if the GDBus server side has not been launched, but the client side want to connect to the bus, the well-known bus name, but it has not exist yet because the server side has not been launched. And if you install the configuration properly, then dbus daemon can activate the GDBus server side process for you to ensure the resource exists there. Yep. Okay. Here's the last slide. This is a rainbow bridge in Taipei City. It links the Neihu and Songshan area. And message bus, just like the bridge, it let the process can communicate with each other. Thank you.
We have maybe time for one quick question. Thank you. If I'm designing a new application, at what point, like, do you have some performance measurements about the overhead of dbus? Like, when should I use dbus? It's simpler, or should I just go to raw sockets because I need very fast IPC, or maybe protobuf or Captain Proto?
It depends on the usage, because dbus use the Unix domain socket, so it relates to the, your disk's I/O. It puts the sockets as a file in your system. So it depends on the your usage. If you are related to a remote process or, I mean, remote communication, dbus cannot do that. And another thing is, it's more like a local communication right now. However, if you read the dbus specification, the RPC part, remote process communication, is also a feature want to have. So, and the pull request is welcomed. Yeah.
Thank you.
So the answer to that question, like 10 years ago, used to be if you want a high-speed connection, pass a file descriptor through dbus and use that as the high bandwidth process. You only use dbus for control messages, essentially. Okay.
What kind of configuration do you need to have dbus start applications? Like, does it need a systemd configuration, or can dbus start it itself?
Okay. Yeah, I remember the first one is you have to install a XML format file which relates to the object into a folder. I forgot which folder. Yeah, and the second one is another file installed related to the dbus. I remember two folders, but I forgot the path. Yes.
So one dbus specified XML format on like the paths you expose, and one service file on the systemd side with sort of matching names on one of the keys, basically. Yeah. Okay, due to time constraints, if you have any more further questions, please find Star Knight in the front. Okay, our next talk would be on Kaspersky OS by Anastasia Pavlova.